students, today is May 6, 2023 and we will be solving the IB Math ESL November 2022 Paper 2 Section B questions. We have already solved the Section A questions on May 4, 2023, that is day before yesterday. That means we have already solved questions from question 1 to question 6. And today we'll be solving question 7, question 8 and question 9 of this paper. And since it is the paper 2, we can use the calculator. I'll be using the TI Inspire 6EX2 calculator. If you have the Casio calculator, you may use the Casio calculator. Okay? So let us start with our today's session. Question number 7, it contains 16 marks and it says a particle moves in a straight line. Its displacement s meters from a fixed point P. This is the origin. This has to be taken as the reference point. At time t seconds is given by this expression s of t equal to 3 times t plus 2 raised to the power of cos t, where t is between 0 seconds and 6.8 seconds, both included, as shown in the following graph. I hope you are being able to see the graph. It is between 0 seconds and 6.8 seconds. This is the vertical axis is for the s, the displacement, and the horizontal axis is for the time t. And the first question, the subpart A of question number 7 is find the particle's initial displacement. Initial displacement means at time t equal to 0. And from the graph, it is very well clear that it is not equal to 0. The initial displacement is not equal to 0. Means at time t equal to 0, the particle is not at the point P. Okay? We have to get the displacement from the point P. We have been given the expression of s of t. We will be graphing this. So let us go to the calculator and it is add graphs. It is 3 times. In place of t, we will be taking the x because the horizontal axis will be the x axis for us. Okay? So it is 3 times x plus 2 the power of cos x. So 3 times x plus 2 to the power of cos x. Enter. 3 times x plus 2 to the power of cos x. Let me just check it once more. Yes, 3 times x plus 2 raised to the power of cos x. And the time will be between 0 to 6.8. Okay. So let me go to the window settings. It is 0 to 6.8. So let me take -1 to say 7. Okay. And this can also be taken as -1 because you see the whole graph is above the x-axis or the time axis. So let me take -1 just to see the axis. -1 to, let me take 20, I am not sure. Okay. Okay, even with 20, I'm not getting the maximum point. So let me make it 30. Let me make it 30. Yeah, now I'm having the maximum. Okay. And what is the thing? Find the particle's initial displacement from the point P. Okay. So over here you can see it is 2, 4, that is, sorry, 1, 2, 4, 5, and 6. But this is a graph, but this can be found from the expression as well. I think so. Let us try. Let us find S of 0, P 0 plus 2 raised to the power of cos 0. And cos 0 is 1. So it is P 0 plus 2 is 2 raised to the power of 1, which is 3 times 2, that is 6. 6 meters. Okay. From this expression, you can get the 6-meter answer. That is the displacement from the point P at t equal to 0. Or else, if you want, you will be needing this graph. So you can see, if you just count the small, the lines, horizontal lines, you see 1, 2, 3, 4, 5, and 6. Okay, the y-intercept is 0, 6. So anyway, the answer is 6 meters. I have done the working above. So I'm just writing the answer. Or else, if you just get the 6-meter answer from the calculator, you can see using GDC. You have counted the horizontal lines to get the y-intercept. You don't have to say counting the horizontal lines, but you can see that using GDC, the y-intercept is 6 meters. So the answer is 6 meters. Okay. The part B. Find the particle's velocity when t is equal to 2. Particle's velocity. Okay. So what is velocity? Velocity v of t will be equal to the derivative of the displacement with respect to t. This is the expression for the velocity. Okay. So, and we have to get v of 2. So let us find the value of v of 2 in 2 ways. I'm showing you both the methods. You don't have to obviously use both the ways, but you can use any of them. Okay. So at x equal to 2 means time equal to 2 means x equal to 2. So first of all, let us get the point where x is equal to 2. I am going to menu and this graph, and then it will be equation templates, line, and vertical line x equal to c. I'll be taking x equal to 2 and enter. See, I have got this line x equal to 2. This is the intersection point. Okay, I want the velocity for this point where x equal to 2. So what I can do is I can go to the analyze graph section and I select this option dy by dx. Okay, and they are asking for which graph, because I'm having the vertical line as well as this one. So this is this graph. Which point? This is this point. See, they have given you the value. It is negative 2.29. So up to 3 significant figures, it will be negative 2.36. Okay. Obviously meter per second, because it is S meters and S in meters and T is in seconds. So the velocity unit will be meters per second. Therefore, the particle's velocity when T is equal to 2 is negative 2.30 meter per second. Okay, so we have got the value of the velocity when time is equal to 2 seconds. But this is one of the methods. I have said that I'll be showing you two methods of getting the answer. What is the second method? The second method is, you have to remember this. The F1x stands for the displacement expression. You have to remember this. Okay? And then we go to the calculator. And next we will be having the derivative. So menu calculus, numerical derivative at a point. The variable is x, of course, and the value is x equal to 2. And we need the first derivative. So, okay. And now you see at x equal to 2, they have given. And we have to now insert the expression. You can insert the expression, but I would suggest that always keep the function expression, because you have once entered the expression, the displacement expression, while graphing it correctly. But if you have to insert the same expression multiple times, then you may be making some error and you may not be inserting or inputting the correct expression every time. And whenever you go wrong, the answer that you will be getting will be wrong. So one time you insert the expression once, and then you store it, and you use the F1x, like that is the F1x stands for the displacement function expression. So instead of putting the entire displacement function expression, I'll be just writing F1x. I'll be differentiating F1x with respect to x, and I want to get the value at x equal to 2. That is what is meant by this thing. So you see F1 x, and this is in bold. This indicates that the calculator knows what is F1, what is the expression of F1. Okay? So, and I come to this point, and I can press this. And you see, we have got the same value, minus 2.29921. So up to 3 significant figures, it will be minus 2.30. Okay? So let me write up to 3 significant figures. Subpart C, determine the intervals of time when the particle is moving away from the point P. So if I try to draw the motion diagram, what happens? This is the point P. And the particle is 6 meters away from the point P at t equal to 0. This is 6 meters. And now, this is the point. At t equal to 0, it is 6 meters. And now the particle is moving away from the point C because the displacement is increasing. It is moving away from the point P. Therefore, I don't know what is the maximum value, but the displacement value is increasing. How can the displacement value increase? when a particle moves away from the reference point. Okay? And in this case, the reference point is the point P. So up to this point, the particle is moving away from P. This is the maximum. This is the maximum point. Okay? And after this point, you see the particle's displacement is coming down. It is almost equal to 0 at this point. This is the minimum point. Okay? It is coming almost down to 0. If it touches the time axis, the displacement will be equal to 0. It is not touching the time axis. That means it is not equal to 0 totally. The particle has not come to the reference point P, but it is very close to the reference point. And how can the displacement decrease? The displacement can decrease if the particle turns. It was moving in this direction. Now it has, at this point, it has turned. It has turned and it has started moving towards the point P, the reference point P. And what is the displacement? The displacement is the shortest distance between the initial point and the final point. Okay? So, as the particle is moving towards the point P, the displacement value is decreasing. The distance, the shortest distance between, that is the straight line distance between the original point and the final point, reference point and the final point, that is decreasing as the particle is moving towards the reference point P. That is meant by this graph. How is the displacement increasing when the particle is moving away from the reference point P? And how is the displacement decreasing when the particle is moving towards the reference point P? Okay? So, up to this point, the minimum, it has come to this point. Okay? Then again, the displacement is increased. And mind you, the displacement, it is a vector quantity. So, and it is positive. Throughout, it is positive. So, the particle is not crossing the point P. If it had moved towards the left, then we would have had a negative displacement. That means the graph would have gone below the time axis. But since the graph didn't go below the time axis, that means the particle did not cross the reference point P. It has come close to the reference point P, and again it has turned, and again it has started to move away from the reference point P. This is the meaning of this fact, that at this point, at this minimum point, it has again turned and it has again started to move away from the reference point P. Hence, the displacement is increasing. Here, so we have to say, determine the intervals of time when the particle is moving away from the point P. That means the intervals of time when the displacement is increasing. Where are the displacement increasing? Between these 2 points, the displacement is increasing, and from this point to up to 6.8. Oh no, not up to 6.8, sorry. Up to this point. We have to get the time for this point as well. So from this point to this point, the displacement is increasing. Again, after this point, it starts moving towards P. Okay? So we have to basically get the time interval of this part and time interval of this part. So for that, this is time t equal to 0. We have to get the values of the time for this point, this point, this point. These 3 points. So these two are the two maxima and this is the minimum point. Okay. Let us go back to the graph. Okay, this is the graph and we have to get the maximum and the minimum point. So we go to analyze graph. Let me have the minimum point first because it is given first. This is the graph and what is the lower bound? This is the lower bound and this is the lower bound and this is the upper bound. This is the value. These are the coordinates of the minimum point. Okay. And now we will be getting the two maximum points. Maximum. What is the graph? This is the graph. And this is the minimum and this is this side. So it will be 0.433. And we need the second maximum as well. So analyze graph, maximum, and what is the graph? This one is the graph and this. Okay. So now we will be saying this is from t equal to 0 to t equal to 0.433. And you see, if you, since I have taken from -1, you are seeing that the displacement is increasing. Means the particle was moving and so at time t equal to 0, it was moving away from the P. It has not started from the point P. We have seen it has started 6 meters away from point P. And not only that, you see the particles uh, displacement from the P is increasing. So that is why we may take t equal to 0, means we can include the equality sign also from the t equal to 0 point. But for this t equal to 0.433 or for the 3.226 or for 6.34, t equal to 6.34, these are the turning points. These are the turning points of the particle. Over here, the particle was moving away from P. Now it is starting to move towards P. Over here, this minimum, again, it starts moving away from the point P. Over here, this maximum, it starts again to move towards P. So these are the turning points. For the turning points, it is neither moving away from the point P nor is it moving towards the point. It is just turning at that. Okay, I'm not going into the gradient and all those stuff. Just understand in a simple language. It is turning. If you see the motion diagram that I have drawn, it is turning. The particle is turning at these points. When the particle is turning, it is neither moving towards the point P nor is it going away from the point P. So therefore, we cannot include the equality sign for these points. Okay, but we can include the equality sign for the point 0 because this is not a turning. Okay. The first interval is from 0 to 0.433. This one is E. Did they give seconds? No, they have just mentioned 0 to 6.8. They have said t is in seconds. So I'm not writing seconds explicitly in the interval. it is 0 to 0.433. This is one of the intervals. And, sorry, I have put this equality sign, which I should not be putting. And the other interval is t is less than or greater than, rather, 3.26. See this one? 3.26, the minimum point. Okay? Don't get confused with this. This was the velocity. This is the minimum point. 3.26. Up to 3 significant figures, of course. So 3.26. Is less than t is less than 6.34. Okay, up to 3 significant figures, it is 6.34. We will be taking the x coordinates because the x axis represent the time. So 6.34. Okay. So we have answered subpart C. Coming to subpart D. The acceleration of the particle is 0 when t equal to b and when t equal to c, where b is less than c. Okay. Find the value of b and the value of c. Okay, we have been given the expression for the displacement. We have to get the expression for acceleration, and we have to see where is the acceleration equal to 0. But let the calculator do the working for us. I don't want to do the second derivative. I don't want to differentiate twice. So what I would be preferring is I would be taking the help of the graph. I will be drawing another graph. I'll be getting another graph rather. Okay. So let us do that. And let us change the window settings because it should be the 0. Let me not take the y minimum as -1, rather let me take the y minimum as -5 so that I get it. Yeah, it is better. So I'm having, because otherwise if I have to read the zeros, so it will be difficult. So now it is fine. And now I want to draw another graph. So it is menu graph function. This is f. What is f2? Given the displacement, how to get the acceleration expression? It will be the second derivative of the displacement. So we'll be doing exactly that thing. Okay. So it is, we will be taking the second derivative of f1x, which is the x of f1x. Enter. See, we have got the graph of the acceleration with respect to time of. We do not need the expression of the acceleration. We need, when is the acceleration equal to 0, we need the times. So we have got the graph, and we are seeing this will not be taken obviously because this is t is negative. T starts from 0. These are the 2 points that we will be reading. Let us read them. Okay. So now we will be reading the 0. So analyze graph and see which graph. It is the red colored one. Lower bound, upper bound. Fine. You see 1.23 and the other analyze graph 0. Which graph? This one. It is 5.69. 1.23 and 5.69. So B equal to 1.23 seconds. And C is equal to 5.69. You may say that this is not equal to 0. Definitely it is not equal to 0, but it is a very small number. You see 10 to the power of negative 11. So it is almost equal to 0. I have tried several times, but I'm not getting a plain and simple 0 for this. Okay. I don't know about Casio, but in TI Inspire, I'm not getting it. So 5.69 is the other value which we will be taking. And then it is part E. Find the total distance traveled by the particle between the times B and C. That means the 1.23 and 5.69. Okay? So when total distance, it is not the displacement. So how do we find the total distance? It will be obviously from B to C. It will be the absolute value of the velocity. This is how we find the total distance. Okay. So, and what is d of t? It is d dt of s of t. And s of t is represented by f1x. So we will be just using this expression to get the total distance. We move to the calculator part. First is, it is the integration. Okay. So we start with the integration. Numerical integration. What are the two limits? Let me take not 1.23, but I'm taking 1.2314. Okay. This is the thing. 1.2314 I'm taking. You may take 1.23, doesn't matter. So I'll be taking 1.2314. 1.2314. What is this one? This one is 6 point, before I had written 6.3397. 6.3397. 6.3397. Okay? And this one is with respect to x, obviously. This will be, first of all, we have to get this modulus thing. So go to this place. This is the modulus. I've got the modulus, and then I have to differentiate f1x. How do I do that? Go to this place. I take this ddx. See, over here, of f1x. f1x. Okay. Now we are done. Now we can just safely press the enter key. Okay. It is 28.1.23 and 5.69, right? f1x dx of f1x. Let us they are saying from B to C, right? From B to C, let me see the graph. From B to C, B is this, C is that. Okay. If I draw the velocity graph, then what? Okay. It is velocity graph will be dx of f1x. This is the velocity graph, and I want from 1.2314 to 6.3397. Let me just take from 1 to 0.8. Let me check what, or let me take from 0 to what was. Let me go to the settings. Take this as 0, this as 6.8, 0.8. This one can be what can be negative 10 to negative 10. Let us see these and let us see if we have to alter these again. We will be altering. Okay. Okay. So we have got this. We have got this. E2. Now we are seeing 1.23 will be, this is 1.1, this is 1.2. So it will be from to here. What is this? Let me get the 0. I'm being suspicious somehow. That's why I'm just checking. This is the 0. Okay. So I will be taking 1.2314. So 1.2314. Let me go to menu and this and equation template line x equal to c 1.2314. Enter. This is the line. So between x equal to 1.2314 to this 3.2558, the velocity is negative. And now we have to get another one is 6.3397. So menu 6.3397. So I come to this graph and I will be drawing another vertical line. It is equation template line x equal to c 6.3397. Enter. What's happening? Between B and C, they have. Oh my goodness. So sorry. It is 1.23 and 5.69. See over here, I have written 5.69. But you should not be wasting your time. I'm sorry. I have wasted some time. 5.69. 5.6896. So let me go to this part. 5.6. Come to this move. I cannot. Let me do it once more. First of all, I go to menu calculus and then numerical integral, and this lower one is correct 1.314, and then this one is 5.6896. 5.6896. 5.6896. And then this one is x, and this one will be the absolute value. And now I come to the derivative. This is x. This one should be f1 x. Yeah. And it is 19.55. Right. Right. 19.6. Up to 3 significant figures. So this is equal to, let me write it in 1 point between 1.3 and 5.69. It will be, if I take dt of s of t, that is what I have done. So I am writing exactly the same thing. Instead of t, I have entered x. That is the only difference. And instead of 3 significant figures, I had taken some more digits, but you will be getting the same answer. It is 19.6. So 19.6 6 meters. So we have completed the 5 subparts of question number 7. We move on to question number 8. The following diagram shows a sector. It contains 13 marks, and the following diagram shows a sector ABC of a circle with center A. This is the sector you see with the center A, ABC. ABC is a sector with center A, and the angle BAC is to alpha that we are seeing. Alpha is between 0 and pi by 2, and angle OEA is equal to pi by 2. OEA is equal to pi by 2, 90 degrees. That means this is the radius. So this is the tangent. A circle with center O and radius R is inscribed in sector ABC. This is the circle. I don't know whether you are being able to see the entire circle. Most probably now you are being able to see. This circle is inscribed within this sector ABC, and this circle is having the center as O and the radius as R. And AB and AC are both tangent to the circle at points D and E respectively. Yeah, that we have seen at these 2 points. The AE and AD, these two are the 2 tangents. So let me just draw this radius as well. Okay. Now they are saying subpart A, so that the area of the quadrilateral ADOE, which one is the quadrilateral ADOE? This one, ADOE, is R square. Area of this quadrilateral is R square over tan alpha. So what we can do is, we do not know how to find the area of a quadrilateral. So what we do is, we divide this quadrilateral into 2 triangles. Okay, we are having 2 triangles. The triangle AOE and triangle AOD. So this is also 90 degrees. Now, first of all, let us find whether these 2 triangles are congruent or not. If they are congruent, then we can find the area of one triangle and just multiply by 2 to get the area of the whole quadrilateral. If they are not congruent, then we have to find the area of the 2 triangles, the 2 triangles area separately and add them. Okay, so let us try to check whether these 2 triangles are congruent triangles or not. Okay? So because AO is common between these 2 triangles, and OE is equal to OD, because this is also the radius, and AE and AD, these 2 are 2 tangents from the same exterior point to the same circle. So AE has to be equal to AD. By AC's side theorem or property of congruency of triangles, you can see that the two triangles are congruent. Or else you can use the right angle hypotenuse side theorem. That is, you are having the right angle and this is the side, this is one radius and this is the other radius of the circle. So these two are the same. And this one, the hypotenuse OA is common. So it has to be the same. Therefore, whichever property you take for congruency of two triangles, you can prove that these two are two congruent triangles. Okay. And then so we can find the area of one of them and multiply by 2. And what is the area of a triangle? What is the formula? It is half times base times height. So I can take the base as this R because they are having the expression that they have given contains R and contains alpha. So I can take the base as R. Therefore, say area of triangle, but okay, area of a triangle is equal to half times base times height. Okay. Now, we have got the base. If you take this to be the base, this is R. You can take this as the base as well. But what is the length of this part? That we have to find. Since these two triangles are congruent triangles, therefore this angle is alpha and this angle is also alpha because the whole is 2 alpha. Therefore, this OA is bisecting this angle. So angle EAO is alpha and angle DOAO is also equal to alpha. Therefore, since triangle AOE is a right angle triangle, we can see that tan alpha, I'm taking tan alpha because I know this side length in terms of R, of course. So tan alpha will be equal to R over in triangle AOE. Tan alpha equal to R over AE. Therefore, AE is equal to R over tan alpha. Okay. Therefore, area of triangle AOE is equal to half times R times R over tan alpha equal to R square over tan alpha. Okay, half R square rather. Therefore, area of the quadrilateral I hope you are being able to area of the quadrilateral ADOE will be equal to 2 times, because the other angle's area will also be the same. So it will be 2 times half times r square over tan alpha. So these two will be getting cancelled and we get the area as r square over tan alpha. Okay. So, and just by showing this part, you get 4 marks. Okay. Now coming to this portion, it says R represents the shaded region shown in the following diagram. I hope you are being able to see. You see, this is the shaded region which is named or labeled as R. And again, this is the 2 alpha, the angle A. The diagram is the same. And subpart B says I, it has 2 subparts. Subpart I is find angle DOE in terms of alpha. DOE. Which one is DOE? Okay. DOE. That means this angle in terms of alpha. Fine. So we do the previous construction again, this diagram. Now we are having 2 congruent triangles. So this part is alpha. This part is alpha. For triangle triangle AOE, in triangle AOE, angle AEO is equal to 90 degree or pi by 2. What did they say? Radians or in degrees? Pi by 2. Okay. It is pi by 2. Angle EAO equal to alpha. Therefore, angle AOE is equal to pi. Pi is the sum total of all the 3 angles of a triangle minus pi by 2 minus alpha. Okay. Pi minus pi by 2 is pi by 2. This is equal to pi by 2 minus alpha. Okay. This one is pi by 2 minus alpha. Therefore, angle AOD is equal to pi by 2 minus alpha. Since triangle AOE is congruent to triangle AOD. Okay. Therefore, this should also be equal to pi by 2 minus alpha. You can take these separately as well. This is alpha, so this is 90 degrees. Therefore, this one has to be pi by 2 minus alpha. Okay. And what is DOE, angle DOE? Angle DOE is equal to angle AOE plus angle AOD. Okay. Angle AOE is this one and angle AOD is this one. These two added together will be giving us this DOE angle. So this is pi by 2 minus alpha. Both are pi by 2 minus alpha. So it is, I can write 2 times angle AOE, or you can write 2 times angle AOT. Doesn't matter which one you are taking. So it is 2 times pi by 2 minus alpha. Okay. Or if you want, you can write it as the 2 and 2 will be getting cancelled. So it will be pi minus 2 alpha. So it will be pi minus 12. Most probably you are not being able to. Pi minus 2 alpha. Okay. Now subpart II. Hence or otherwise find an expression for the area of R. Okay. Area of R. What is R? R can be thought of as, this is the area of the quadrilateral that we had found before. This is the area of the quadrilateral that we had found before. And the highlighter is hiding the, so this is R. This is R. And this is the area. This is the circumference of the circle. And this one was 2 alpha. Now, and this is O. So, this is the total area of the quadrilateral that we had found before. It was R square over tan alpha most probably. Yes, it is R square over tan alpha. From this area of the quadrilateral, if we subtract this area, if we subtract this area, this is the area of this sector. If we subtract this area from the area of the quadrilateral, we get the area R, the shaded region. Okay. So we will be doing exactly the same thing. We will be taking the area of the quadrilateral, that is r square over tan alpha, r square over tan alpha, and minus the area of the sector. What is the formula for area of a sector? It is half theta r square. Okay. If you do not remember, you had the formula booklet with you. You may consult the formula booklet. So this will be, I'm starting from here. It is area of the quadrilateral will be r square over tan alpha minus half theta r square. What is theta? This is the angle DOE, which we have found to be equal to pi minus 2 alpha. So half theta, that means pi minus 2 alpha, and r square is r square. So this is the expression. If you want, find an expression, they have said, if you want, you can just take the r square common. That is up to you. You can keep this as it is, r square. This will be the area of the region R. Equal to this. And if you want, at most what you can do is you take r square common. This is the area of the quadrilateral minus half theta r square. Theta is pi minus 2 alpha. So in place of theta, I have written pi minus 2 alpha. R square is, the radius is r, so it is r square. Next, we have the part C. Find the value of alpha for which the area of R is equal to the area of the circle. The area of the circle is obviously pi r square because the radius is r of center O and radius. There's only one circle, this complete circle visible. So this is with radius r and center O. So they are saying find the value of alpha. So we may go for the graphing, but let us first of all, if possible, let us first of all do some simplification. So the area is r square over tan alpha minus half pi minus 2 alpha r square is equal to area of the circle is pi r square. Okay? Because area of the circle formula is pi r square. You may consult the formula booklet. Then what we can do is, because this equation is having two variables, alpha and r, there is a single equation, but we are seeing r square is present in every term. So we can divide the entire equation by r square. So these will be going. And the equation becomes 1 over tan alpha minus half times pi minus 2 alpha equal to pi. Okay, and this will be 1 over tan alpha, and this is pi by 2 minus pi by 2, and that is plus alpha. Minus times minus is plus, so it is plus alpha. And if I bring the minus, the pi to this side, means if I add minus pi to both the sides, I get this as 0. you can okay, let me just see, let me just complete this part, and I'm saying another way. So 1 over tan alpha minus pi by 2, and minus pi is minus 3 pi by 2. So plus alpha minus 3 pi by 2 equal to 0. So you can graph this expression and get the zeros. Or else, I don't know whether you'll be getting multiple zeros or a single zero. We have to check. Or else what you can do is, you can have the equation as, or 1 over tan alpha plus alpha is equal to 3 over 2. Over here, instead of adding minus pi to both the sides, if we add pi by 2 to both the sides, we get this. So if you have the equation in this form, you have to graph 1 over tan alpha plus alpha, and another graph will be for y equals 3 over 2, and then you will be getting the intersecting points, coordinates. Okay. For this equation, you will be just getting the zeros, or the zero. So I'm taking this one. At graph is F4 1 over tan alpha. So 1 over tan alpha. So alpha means I'll be taking x plus x minus 3 over 2. Minus 3 over 2. Minus 3 over 2 into what was the alpha range? Alpha was between 0 and pi by 2. Okay. So menu, window settings, 0 and pi by 2. Let me take 0 and pi by 2. So, and because alpha was between 0 and pi by 2, those were not included. Therefore, I'm taking 0 and pi by 2. This is pi divided by 2. Know anything about y min and y max? First of all, let us take these two limits and let us see how does the graph change. Okay. Okay. Fine. So there should be only a single zero. Where is because this should be equal to 0. So 1 over tan x plus x minus over 2. Okay, now analyze graph 0. No zeros found in that region. R square over tan alpha minus half pi minus 2 alpha r square. This should be equal to pi r square. Yes, and I have cancelled the r square, so it becomes 1 over tan alpha minus half pi minus 2x minus pi minus x alpha plus equal to pi. This is 1 over 2 alpha minus pi by 2 plus alpha minus pi is equal to 0, and it is 1 over tan alpha plus alpha minus, sorry, the pi by 2. That is why. That is why I am not getting them. Okay, so let me take another graph. What is happening? Many mistakes. 1 over tan alpha plus x minus p over 2 times pi. And enter. Okay, now I can take the window settings. I can go to the window settings. This will be 0 and this will be pi by 2. Okay. Okay, now you see you're getting a very well defined 0. My goodness. It is not correct because it has included the x. X is also within the over this denominator 2. Okay, let me just write 1.5 in place of over 2. In 1 over tan alpha plus x minus 1.5 times pi. I hope this time I'll be getting some. Plus x minus 1.5 times pi. To zoom window settings 0 and this is pi by 2. Okay. But tan x plus x minus pi may be correct this time. Let us analyze the graph. It will be the 0. Okay. Since the expression is correct, I have ultimately entered the expression correctly. Therefore, I don't have any reason to suspect the correctness of this, the coordinates of this point, the 0. So I'm taking 0.219 as up to 3 significant figures as the value of alpha. 0.219. Therefore, alpha equal to 0.219 up to 3 significant figures. This is in radians. Now I'm becoming a little bit more cautious on because I don't know how did I make mistakes. The second mistake I have, yeah, I could get it that I did understand that I have made a mistake, but the first one I was just going on wandering order. So question number 9, maximum mark 16. The time worked T in hours per week by employees of a large company is normally distributed with a mean of 42 and standard deviation 10.7. Okay, so it is a P is a normal distribution variable. Pick another color. P is a normal distribution variable with mean as 42 and the variance will be 10.7 square. Variance is standard deviation square, so it's this. Okay, but again I am saying it is not mandatory that you have to write this statement. Even if you don't write this statement, your marks will not get deducted. You will not be getting even a single mark subtracted. Okay? So, mean is 42 and standard deviation is 10.7. Fine. Now coming to subpart A. Find the probability that an employee selected at random works for more than 40 hours. So, P greater than 40 is equal to, and we have seen the mean is 42 and standard deviation is 10.7. So now let us go to the calculator. This is the calculator. Yeah, this is the calculator. So let us go to the statistics, distributions, normal CTF, lower bound greater than 40. So the lower bound has to be 40. And the upper bound I am giving as 99999. But if you say that this doesn't have any meaning, how can you have so many hours in a week? Then you can just give 24 into 7, multiply and give the answer. Give the product over here as the upper bound. Doesn't matter. Okay, if you want, I can show you. This time I have taken this. Let me see what value do I get. This will be 42 and this will be 10.7. Okay. So this is 0.574 to 0.574 up to 3 significant figures. Using norm CTF. Now let us check what is 24 times 7. 168. So now we again go to the statistics, distributions, normal CDF, lower bound is 40, upper bound is 168, mu is 42, and sigma is 10.7. Okay. You see, you are getting exactly the same value. Okay. Subpart B. A group of 4 employees is selected at random. Each employee is asked in turn whether they work more than 40 hours per week. Find the probability 4 employees are taken. Find the probability that the 4th employee is the only one in the group who works more than 40 hours per week. That means the first 3 employees work less than 40 hours per week, because for normal distribution for continuous variables, it doesn't have any meaning to say that a particular employee works exactly 40 hours, because time is a continuous variable. Exactly 40 hours and not 40.000 after a long trail of zeros followed by a single one hours. It is not that. You cannot guarantee. Okay. So you cannot measure a continuous variable with absolute accuracy, accurateness. So that is why it is either greater than 40 or less than 40. So that means the first 3 employees work for less than 40 hours per week. Only the 4th one is working for more than 40 hours. Okay. And we have found the probability of working more than 40 hours to be equal to 0.574. This is up to 3 significant figures. We are having more number of digits over here. Fine. So that means the first 3 employees are not working for more than 40 hours. And the 4th one will be this. So let us do one thing. Let us store these variables. You'll be coming to know why am I storing this. So I am doing this as control answer. This is the number. And then I'm storing it as more than 40 hours. So let me write as M and F, more than 40. Enter. So this is the variable. Instead of writing so many digits, I can just write MF. Okay. And for less than 40, what will be the probability for less than 40 hours? Obviously, the total probability has to be equal to 1. And there are only 2 possibilities. Either it will be more than 40 or it will be less than 40. It cannot be equal to 40 for a continuous variable. So it is either more than 40 or less than 40. And the sum total of more than 40 plus less than 40 probabilities should be equal to 1. So since the more than 40 probability is this, the less than 40 probability will be what? 1 minus this. So I'm just doing this to get the less than 40 probability. 1 minus, this time I will be bringing, this is the MF, you see, and I enter to get the less than 40 probability. So the less than 40 probability, again, I store it in some other variable. I'm taking LF for that. So this is control answer and will store LF. Less than 40 probability. Okay. So now we have to say, we have to get the product. The first employee is working for less than 40 hours. So it is the LF. Therefore, that is why I have, now you can understand why did I store these. Because instead of writing so many digits repeatedly, 3 times for the first employee, for the second employee, for the third employee, I have stored the number in this variable and I'll be just writing that. Now I get LF times LF times LF. The first employee is not working for more than 40 hours. He or she is working for less than 40 hours. The second employee is also working for less than 40 hours. Third employee is also working for less than 40 hours. The fourth employee will be working for more than 40 hours. So it is MF equal to 0.0443. So it is 0.0443. So let me just write it over. I can write it over here. It is T of T1. T1 is the time taken for the first employee. T1 less than 40. And means intersection. So, and T2 less than 40 and T of T3 less than 40 and T of T4 greater than 40. And because it is and, these should get multiplied. That we know. And is multiplication or is addition. This part we know. Okay. So we have found the probability of T less than 40. Just let me write that. Probability of T less than 40 is equal to less than 40 was equal to 0.425863. So it is 0.426 up to 3 significant figures. It is 0.426. Okay. 0.426 up to 3 significant figures. And this is 1 minus T of T greater than 40 is equal to P of T less than 40, which is 0.426 up to 3 significant figures. So this is the sum to the product, which should be equal to 0.0443. 0.0443. 0.0443. So this is the answer. Okay. So this is the answer for subpart B. Now we come to subpart C. It has 2 more subparts, I and II. A large group of employees work more than 40 hours per week. More than 40 hours per week. I says an employee is selected at random from this large group. Find the probability that this employee works less than 55 hours per week. Now, this is a case of a conditional probability because you are taking a group of employees. All of them are working for more than 40 hours per week. So, given that whoever you are selecting is working for more than 40 hours per week. So, this is the given condition. So it is a case of a conditional probability. You have to find that the employee that you are selecting is working for less than 55 hours per week. Okay. So this is what. So this is P of P less than 55, given that P is more than 40. Okay. And we know what is T more than 40. P of T more than 40. We have got. So we have to get the numerator will be equal to, this is P of T greater than 40 but is less than 55 over P of T greater than 40. This is the conditional probability formula. We know the denominator value. We have to find the numerator. So let us find the numerator. So menu, statistics, distribution, normal CDF. It is between 40 and 55. So 40, 55, mu was 42, and standard deviation was 10.7. Let me show you once more. You have forgotten. I'm showing you. Okay. I have entered and I have got this value. Now let me show you once more the mean and standard deviation value. Yeah. The mean is 42, standard deviation is 10.7. So this is equal to 0.461945, 0.46491, 0.461945, 0.461945, 0.461945 divided by the more than 40, it was C 0.574137, 0.574137. The 0.574137. 417, which is equal to the upper part will be the answer, this one, numerator, and the denominator will be more than 40. So let me just take the more than 40 MF. Okay, and enter. So it is 0.805. Okay, up to 3 significant figures. 0.805. Up to 3 significant figures. Okay. So we are done with I. Now coming to II. 10 employees are selected at random from this group. Which group? Who are working for more than 40 hours but are working less than 55 hours per week. So this is also a case of a conditional probability. Find the probability that exactly 5 of them work less than 55 hours per week. Okay, okay. We have a conditional probability in that sense that the group that we have selected, those people work for more than 40 hours, but work maybe working less than 55 hours or maybe working more than 55 hours per week, but definitely are working more than 40 hours. Okay. And out of this group, 10 employees are selected. Either they will be, all of them are working for more than 40 hours. That is definite. But for the 10 employees who are being selected, who have got selected, some of them will be working for more than 55 hours. Some others will be working for less than 55 hours. And they are saying exactly 5 out of 10 are working for less than 55 hours per week. That means 5 others are working for more than 55 hours per week. Definitely. Okay. Because you are having only two possibilities. Either they will be working for less than 55 hours per week or they will be working for more than 55 hours. So there are two possibilities. And the number of trials, the number of employees who are selected is also fixed. It is 10. And the probability of success means probability that a particular employee is working more than or less than is taken as the success. So the probability that a particular employee is working for less than 55 hours per week, given that he or she is working for more than 40 hours per week, is a constant. It is not changing from employee to employee. That the probability is different for the first employee, it is different for the third employee or second employee. It is not varying from employee to employee, it is fixed. It is independent of the employee number. Whoever we are selecting, the probability stays the same. That is why we can think of the binomial distribution, where the probability of success is this one. Okay. So the probability of success, I'll not be taking up to 3 significant figures. Up to 3 significant figures, it is 0.805, but I'll be taking, what is it? 0.840459. I'll be taking all of them. Always you take more number of digits for the intermediate calculation. Only for the final answer do you write the up to 3 significant figures. Okay. So this is the probability of success. So, exactly 5 of them. So I had taken, let me take X. So I can write X over here. X is a binomial distribution variable where n is 10. And what is the probability of success? It is, let me write 0.80459. Okay. So exactly 5 of them will be working for less than 55 hours per week. So we go to the calculator, 80459. Menu, statistics, distribution, and this time I'll be selecting, I always select binomial CDF because my students, some of them get confused with whether to use the binomial CDF or binomial PDF. So recommend, I always suggest that you go for the binomial CDF. You may use the binomial PDF as well. Number of trials is 10 and the probability of success you are not being able to see now. It is 0.80459. 0.80459. And lower bound is 5. Upper bound is 5. Okay. It is 0.0242. Up to 3 significant figures, it is 0.024. Okay. So I can write using I have used binom CDF, so I am writing binom. You can write the values that you have entered. 10, comma 0.80459, comma 5, comma 5. The answer is 0.0242. Answer is 0.0242. Let me write the probability. Probability is equal to 0.0242. 0.0242. It is known that probability of T between A and B is 0.9404. So it's all good in drawings. Please excuse me. This will be the normal distribution curve. Will be of this shape. Like this, some of this shape. And they are saying between A and B, okay, so between A and B, this may be A and this may be B. This is the mu. It is 0.904. The probability, the total probability is 1. The area under the curve, the total area under the curve is 1. That is because it represents the total probability. and the left side is 0.5, the right side is 0. And between these two, you have this region, it is 0.904, the probability. Okay, and they are saying that the this part b of t greater than b, that means this one, is equal to 2 times b of t less than a, is this one. Say, therefore, and where a and b are numbers of hours per work per week. An employee who works fewer than 8 hours per week is considered to be a part-time employee. The part D says find the maximum time in hours per week that an employee can work and still be considered part-time. Okay, so we have to basically find this one. A. This is the maximum time that the employee can work per week and still be considered as a part-time employee. Okay? So basically, we have to find the value of A. How can we find that? We know the total probability is 1. And if we subtract this part, we will be getting the probability of this section plus this section. That means probability of t greater than b plus the probability of t less than e. Yeah. So probability of t less than a plus probability of t greater than b is equal to 1 minus 0.904. Okay, which is equal to 1 minus 0.904. It is 0.096. 0.096. 0.096. Now, they have also given us another relation. Relating t is probability of t greater than b and probability of t less than a. Probability of t greater than b is equal to 2 times probability of t less than a. So I can, in place of this, I can write this to be equal to 2 times probability of t less than a. This is p of t less than a plus p of, 2 times p of t less than a is equal to 0.096. And it is nothing, means when you see probability, something, don't get confused. If I take this as, say, this will be a number. So if I take this as k, this will be 2k, and 2k plus k or k plus 2k will be equal to 3k. Where what is k? K is probability of t less than. Okay, you think this way. Just after coming to this equation, you cannot add. How can I add? I don't know. Why? Probability is just a number between 0 and 1. So I'm taking it as k. So 2 times the same thing will be 2k. Adding them, we will be getting 3k. So it will be 3k. I'm not writing k because in place of k, I'm writing what is the k? Probability of t less than a is equal to 0.096, or probability of t less than a is equal to 0.096 over 3, which is equal to 0.032. 3 times 3 is 9 and 3 times 2 is 6. Now we have to get the a, and we know the probability. So obviously we will be using the inverse normal function. Okay. We go for inverse normal, statistics, distribution, inverse normal. Area is 0.032. And the mean was 42. And the standard deviation was 10.7. Okay. So it is 22.18. Therefore, A, using inverse normal, let us write using inverse normal, 0.032, comma 42, comma 10.7. A is E. 22.2 hours per week. A and B are number of hours work per week. So we have completed the question number 9 totally. A, B, C, yes, yes, and D, yes. So we come to the end of this question paper. We have solved it completely. And thank you for staying with me till the end. And all the best, all of you. May you get very easy papers. Easy and difficult, these are relative terms. May you get the papers which you will be able to solve. Solve them, read the questions carefully, and write your answers carefully. Copy the correct values from the calculator or from the question. And finally, equally important is recheck your answers. Okay? All the best. So, bye bye.